Spatial patterns are a lot like and are related to number patterns. We'll start with a starting design, and then we'll add a repetition, maybe the design itself, maybe part of the design, and keep going, and we can find out what that pattern is. We'll be able to make a rule, so turn that into a mathematical formula that works all the time. So the key ideas is, one of the key ideas, we have a spatial pattern there, and that's a shape, geometric shape, and it's a number pattern. So there's 4 of these matchsticks that make this pattern. We need 8 of the matchsticks to make this pattern, and we need 12 matchsticks to make that pattern. As you can see, they're all sort of going from the original matchstick diamond. So it starts with a simple geometric idea, and then we add on repeated shapes of the same design. So for this one, we got 8 because we didn't share any common edges. If we connect with an edge, then the repetitive shape will be a subset. So this is our starting design, but as you can see, when we add another one, this one was already there, so we only need to add that. So we only need to add 3 each time. So this one is 4, because 1, 2, 3, 4, but this one is 4 plus 3. So if we count 1, 2, 3, 4, 5, 6, there's only 7 matchsticks in there. And this one will be 4 plus 3 plus 3, so we can represent that in numbers. So it's generally, as I just did, converted it into a number pattern, and a common difference is observed. So we can see how much they're going up by. The common difference, such as the number of sticks, needs to be added to create the next term. So if I've got one shape in this one, I need 4 sticks. So this one doesn't share an edge because I add 4 sticks when I need 2 squares. For 3 squares, I add another 4. So this is the common difference between them. And then we can develop a rule from that that tells me how many sticks are needed for a certain number of shapes. So for example, if we use this one, the number of sticks is 4 times the number of shapes. And if we use n for the number of sticks, equals 4 times whatever those shapes are. So that's the kind of thing we're working toward. Rules can be found that connect the number of objects required to produce the number of designs. So here again, a hexagon has 6, and we add 6 each time. And remember, multiple, oh, I said the word multiple because that's what addition, that's what multiplication is multiple addition. So the number of sticks used equals 6 times the number of hexagons. So that allows us to work that out without having to draw out all the hexagons. Well, first we'll start with drawing. So here is our base shape. This one has 1, 2, 3, 4, 5. What I'm going to add on is just these ones. So I've got 2 of the kind of H-looking shapes, but I've only added 3. And then I add another 3. So let me show you what the next ones are going to look like. So we've added 3 more on this one. So we have sort of 4 H's, but we only need to add 3 to the original 5 each time. And then we add another 3. So that'll be the next one. So write a spatial pattern above is a number pattern regarding the number of sticks. So as I said, the first number of sticks was 5. That made our initial pattern. And then we added 3 to make 8. And I might just put a little something in there to remind myself how I got there. Because if I count 1, 2, 3, 4, 5, 6, 7, 8, I've got 8. And then if I add another 3 and another 3 and another 3, that pattern just continues. And that's how I can work out how I'm getting from here to there. Describe the pattern by stating how many sticks. Okay, so 5 sticks to start the pattern, and an additional 3 are needed. And I'm going to put the word term in there because when we make it into a number and when we start using algebra, we're going to call that a term. Draw the next 2 shapes in this spatial pattern. This one has 3, and it looks like we're going to add 3 each time. And if we're doing that, this is what the next ones look like. You see we've added another triangle of 3 and then an additional triangle of 3. So if we go through and count them all, one triangle has 3 sticks. 2 triangles has 1, 2, 3, 4, 5, 6. And I think you might be seeing a pattern here. Here's our little pattern. It looks like I'm adding 3 with each time. So we get to 9 plus 3 is 12 plus 3 is 15. So we're going to write a rule connecting the number of sticks required to the number of triangles produced. So the number of sticks is going to be equal to 3 times the number of triangles. And that's what we proved up above. Every triangle has 3. So now we can work out, we can use our rule, which maybe I can make it that. Number equals 3 for every triangle, number of triangles. I don't know, that looks pretty good to me. Predict how many sticks we need to make 20 triangles. We want to know the number of sticks equals 3 times the number of triangles. So the number of sticks equals 60, therefore the number of sticks is 60.